In this video, we're going to explore more derivatives with exponential functions. So, the first example we're going to be looking at is going to be the function 2e to the x to the third minus 3x. That's all in the power. So we need to find the derivative of this. So the derivative is basically going to be writing this whole thing as it's given, and then multiplying that by the derivative of the power. Okay, the derivative of this. Oops, like that. Okay, so that should give us, let's see, I'm going to write that 2 because that's a constant. I'm going to write that first. Now I'm going to write the derivative. So the derivative of this is 3x squared minus 3, right? Using the power rule. So it's 3x squared minus 3. And then I'm finally going to write the e to the x to the third minus 3x. Okay? So you can try to leave it like that, or you can just distribute the 2 to these guys and make it 6x squared minus 6 multiplied by e x to the third minus 3x. Right? It's up to you. But this is basically the derivative. Now the second example is going to be this function. So the square root of e 2x squared. Okay, notice first of all that we can write this as e to the 2x squared to the 1/2. Okay, and we're doing that so that we can use the chain rule when we take the derivative, because the chain rule requires us to use the power as a fraction rather than the square root, right? Because the square root will make things very complicated and not easy to see. So the derivative of this will be, following the chain rule, we start from the outside, so we bring that 1/2 as the constant, we copy the e to the 2x squared, and then the power decreases by 1, so it becomes negative 1/2, right? So 1/2 minus 2 minus 2 over 2 is negative 1 over 2. Okay, so now we're ready to take the derivative of the inside. So I'm going to multiply that by the derivative of the inside, which is this. Okay, so that will give us 1/2. So I'm going to copy everything in the first part times the derivative of this. And derivative is going to be, of course, writing the given, right? And then taking the derivative. You see, this is all the chain rule again. So now I'm going to take the derivative of the 2x squared, because we're going all the way inside, right? We're going to the power. So that is equal to, let's see, so I'm going to copy this, 1/2 e to the 2x squared to the negative 1/2 multiplied by e to the 2x squared times the derivative, which is 4x. Okay, so 4 and 2, as you can tell, that will become 2. So as a result, we will have 2x e to the 2x squared divided by the square root of e to the 2x squared. No, I should write that better. Sorry, like that, e to the 2x squared. So now what is that equal to? Notice that e to the 2x squared divided by the square root of e to the 2x squared is going to simply give you the square root of e to the 2x squared, right? Think of radical 2. 2 divided by radical 2. I'm just going to give you as a side note, 2 divided by radical 2 is going to give you radical 2. Okay, that should be a fact. Okay, so for using that technique, using that algebraic fact, we will get 2x square root of e to the 2x squared, right? And guess what? This is not the simplified form yet, because we can write this once again like this, e to the 2x squared raised to the power 1/2. And guess what? The exponents will multiply, right? Because we're taking the power of a power, right? So we will have 2x multiplied by e to the 2x squared multiplied by 1/2. And that, ladies and gentlemen, turns into simply 2x e to the x squared. Okay, so that's your final derivative for this example. Right? Why? Because these 2's, they cancel, right? These 2's. So you wind up with x squared in the power for the e. Okay, so I hope that you found this video useful. Please subscribe to my channel and I'll see you in my next video.